Okay, problem number 3 asks us to create the following plots of the output spectrum for a nonlinear mixer with 2 input signals at 6 megahertz and 9 megahertz. So first it wants a plot of the first 3 harmonics and a second plot of their cross products. So let's do the plot of the harmonics first. We know their fundamental frequencies because they're given of 6 megahertz and 9 megahertz. 6 megahertz, and the other is 9 megahertz. These are both given in the problem. So if we want to go out to the first 3 harmonics of the 2 signals, we can go ahead and find our other frequencies there, or our harmonic frequencies, F2 and F3. So F2 would just be double that. And F3 would be triple. And the same thing for the second signal. Our F2 is going to be double that. And our F3 is going to be... So to create a plot of this, a plot of our harmonics, we'll have to lay this out with frequency in megahertz on the x-axis, and we can label these. We notice we're all factors of 3 here, so let's just label these 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. That would be as high as we need for this particular plot. So now we're doing part A, which is a plot of the first 3 harmonics of these signals. So we know 6 and 9 are our first harmonics. And I can use different colors for our different signals. So for signal A, we have 6 for our first harmonic. For our second harmonic, we have it at 12. And for our third harmonic, we have it at 18. And these have a reducing amplitude. No, we don't really have a y-axis, but it's just generally getting less as we increase in frequency and go to the higher harmonics. So for the second signal, we have our first harmonic at 9. We have our second harmonic at 18. So we have a doubling of the overlapping of the signal there. And the next at 27. So that is the plot of our first 3 harmonics, which is part A of number 3. So now we need part B. And to do part B, we again need to make our cross product table for 1 and 2 for M and N. So M, N, and then finally the cross products in megahertz. So these will be 1, 1, 2, 2, 1, 2, 2. And we plug these in, knowing the values we had from the previous problem. 6 and 9 are original FA and FB. So 6 plus or minus 9. And these are all going to be absolute value, of course. All right, 6 plus or minus 18. 12 plus or minus 9, and 12 plus or minus 18. All right, so just 2 times both for that last row. And then we calculate those out, take absolute values. We end up with 3 and 15. Then we have 12 and 24. 3 and 21, and 6 and 30. For our calculations of the cross product. So those are where those cross products are occurring. So now we actually have to plot those out again using the same kind of plot that we just did. And we'll label again on the orders of 3. 6, 9, 12, up to 30 should be far enough for what we need. So these cross products are going to occur at these frequencies. So let's start drawing those in. We have 3 and 15. So 3 and 15. And then we have 12 and 24. So 12, 24. 3 and 21. We have an additional 3 and then 21. And then we have 6 and 30. So at 6, that, and at 30, we have that. All right, so now we have plotted the cross products of that table. We've plotted those onto the frequency, so this is our F in megahertz. So that's the plot of our harmonics with the cross products included. Note it does not have our original harmonics still on that plot. If you wanted to put the two together, you could, and plot them all on one big plot. You may want to use different colors to differentiate if you did that. So you could combine the two plots to show all of your data at once.